You're listening to China Manufacturing Decoded from the Sofeast Group. Hello, you're back with Adrian here. Renaud joins me. Hello, Renaud.
Hey there, how are you?
Good, thank you. And you?
Not bad. Yeah, not bad. Surviving the heat.
Yes, well, I can't say we have an awful lot of heat here in the UK. Very different to South China, but still we take it as it comes. So, what we're going to be doing in some forthcoming episodes, Renaud, is we're going to be covering common questions and issues that we have from customers, and we genuinely get asked this kind of thing from our customers often when we're working with them on new product development projects and things like that. And one of the first topics then would be the prototyping and testing part of a project. And you've highlighted a couple of questions that we would typically be asked. And we're going to go through those questions today, which are, again, it's about prototyping and testing. Lots of things need to happen during these sort of phases, as we've discussed, regarding new product introduction and things like that. But let's focus down on these questions specifically. The first one, Renaud, how many iterations of the prototype will be needed? That's a good one, isn't it?
Yeah, and that's something you probably can't answer from the beginning. I mean, if your product is, I don't know, like a square box, or I should say a cubic box, right, without any complexity, then probably one iteration is sufficient. You go with, let's do some 3D printing, or if you want, I don't know, maybe some CNC, carving out the material from a block of plastic, and let's see how it feels. And then, assuming it's in plastic, let's go for tooling after that if all looks good, right? And maybe in parallel, let's work on the surface treatment, the color material and finish, all these little details, about what it's going to look like. And this could be pretty fast. And maybe it's metal, so it's even faster. Maybe it's sheet metal that is formed, just cut flat and then formed and what's the right word for that? Bent and cut and so on. Okay. On the other hand, if you're trying to, I don't know, to go in competition with Mr. Bezos and Mr. Musk, and you want to make rockets, right, to throw stuff in orbit or even further, well, you're going to need a bunch of prototypes. And at the same time, you're also going to need to do a bunch of simulations, right? So the more you go into big and expensive things, the more you're going to use advanced software for simulation, right? It's very common in aerospace because you can't, every time you want to test something to confirm an assumption, you can just, okay, let's make a prototype, Hey, yeah, this new Airbus we're developing, let's make a full-blown prototype and let's see, let's see if we can rip the wing off if we do that, No. You do a lot of advanced simulations, right? But in our world of relatively simple products, they might be, okay, relatively simple, okay, compared to rocket science, right?
Well, yes.
Yeah, and usually not enormous, not with a very high price tag per unit. Well, usually you plan ahead and you do some design and you make some prototypes, and it's cycles, right? So you're gonna start. There's a certain logic to it, basically, and maybe we can cover that. But you're going to go directionally, where you want to go. But there's also a lot of discovery. It's not like you're starting, I'm starting in Los Angeles. I'm going to walk to New York City. And then when I get to Grand Station, or Penn Station or whatever. Okay, that's where I am. I arrive. When you develop an innovative new product, you're not really sure where you're going to land, right? Because you're going to discover the technical challenges and difficulties, maybe to work around. Maybe you're going to think of a new, better way to do things.
Yeah.
Maybe you will put together prototypes and show it to your users, and then they will say, well, that's not really up to the job, so you're going to have to try something different, right? And you're going to work with some specialized suppliers. Maybe you think you need a display that does this way and that way, and then you talk with display suppliers and they say, well, that's what's possible. That's it, right?
Mm.
or a battery or whatever. And then you have to do with whatever can fit your budget and your timelines. Okay. If you want to really go leading or bleeding edge and you want to jump to the next technology and so on, well, you might be pretty disappointed because you might delay your project for maybe 1 or 2 years. And then when you actually put things together, well, it doesn't work the way you expected. It's not mature yet, So there's all kinds of trade-offs to make, all kinds of decisions, which is normal, right? So it's not like you start in Venice Beach and you're going to Penn Station. No, that's not what's happening. You're going in a certain direction, and at some point you might give up. At some point you might drop half of the features and simplify the product, which is usually a discussion we get into when some customers realize that they've been a little bit too ambitious, maybe, right? Maybe they need to reduce their development cost. They would need to cut the development timelines, and they also want to make the product unit cost lower. Well, and they want to reduce the overall technical risk on the product. Sometimes you just simplify, and it makes everything faster, cheaper, less risky, So there's a lot of things that typically happen, okay? Typically happen. Now, if you know exactly what you want to do, if you say, the way a lot of Chinese companies used to do and still do, they pick a product and they say, we're just going to do something that looks the same, but simplified inside and everything, like those copies of the BMW X5 and so on that we used to see a lot on the roads in China. The shell, was already decided from the beginning, and then they just had to kind of make it work under the trunk, right? So maybe a car is not the right example because I'm sure there's a lot of iterations and a lot of complexity, of course. But when we do something like this, it's a little bit more like, okay, yeah, we want to go to Penn Station. We know from the beginning, But in a lot of other cases, that's not the case. So if you look at, some products from big brands, you'd be shocked at how many iterations they've done, on the aesthetics, on the functionality side, on the firmware side, everything. It's crazy, but they have big teams working on it, plus their suppliers, who join the effort at some point and so on and so forth. And it's, there's dozens and dozens of iterations sometimes, right? But there are big versions and small versions also. So when we say iteration, what exactly does that mean? Is it a full-blown iteration, meaning that we are planning that we'll develop this toaster with a special function of, also for cooking bacon, okay, let's try something here, let's try to think of a way to do it, do some design work, build a prototype, test it, see how it fails, see all the issues, and have a plan for the next iteration. Maybe that's one iteration cycle. Okay. But in some cases, in big projects, it can be a bit difficult to see what exactly was a major jump from one version to the next, or a jump from a subversion to the next subversion, if that makes sense.
And I'd like to ask, one of the reasons why people ask this question is, of course, I mean, you've just explained, you can't just say, oh yeah, you'll need 10. Yeah, it's not possible, because this is going to become more apparent depending on the products and the way that development is going and the changes that are being made. But people ask because primarily they're concerned about the financial aspect.
Yeah, and the timelines. Yeah, of course. And maybe they think, well, this, and that's not really the right way to think about it, but it makes sense. They're thinking, well, I ask 3 suppliers, and they're going to ask, like 3 maybe design houses, or, 3 companies that can help me on the design. This one tells me, in a couple of cycles can be done, and, with high confidence. We feel they have high confidence. And this other one says, well, that might be, 2 iterations if things go well, but it might be, 3, 4, or 5, who knows, and they start to ask all kinds of questions, etc. Which one are you going to pick? Well, if you've never done these kind of things, basically you don't know what you're buying, what kind of service you're buying. If you don't know the risks, you don't know what questions to ask. Yeah. Probably you're going to go with the guy who says, just 2 iterations and we get it done, no problem, right? It's human nature, right? But then maybe that guy is just over optimistic and he wants a big payment first. So anyway, you're hooked. So actually it's your risk more than his risk. And, it's just a very self-confident salesperson that you're talking to. But the other one who's asking all kinds of questions, well, he's trying to see, okay, are these guys full of fluff? Like, do they know what they're doing? Do they even have a clear idea about what result would look like? Because what we see very often is people come to us and they say, well, we want it to be really nice. Right? Okay, but what does that mean? It's got to look like great. What does that mean? Like, make it tangible, it's got to be like an Apple product. We get that countless times. And then we say, well, first, you're saying that, but you don't really know the criteria of, that the Apple quality engineers give their suppliers and they hold them to, right? You don't know. You've never seen their product specification sheets and checklists and, whether they set the tolerance for this and this process and so on, right? And you don't have 10,000 people on the ground to follow production, right? And you're not going to do all the crazy things that Apple does just to be insanely good, right? Like you can't say, well, I reposted something in LinkedIn a few weeks ago, but that was funny, but it's some crazy examples where Apple said, well, we want some really, really thin batteries. And then all the big battery manufacturers really wanted to work with them, but they say, no, I can't do that. And then Apple actually designed its own battery, not just the battery packs, but the battery cells, Are you going to get down to that level of details, hire some of the best, most experienced professionals in that field just to get that? You're not going to push the envelope like Apple does. Or if you want something to have a hole to be cut in a very specific way, it's got to be done by laser and only that kind of machine can do it. Apple actually bought the manufacturer of the machine and took all the production capacity for themselves, right? And I guess they sort of kicked out the other customers and say, no, we stop producing for you for a while and so on, right? So you're not going to do these kinds of things. So don't compare yourself to Apple. That doesn't make any sense. But the problem is when you go into a project and the customer has that mindset, well, what happens is that when they get prototypes, they say, not good here, not good here, not good here. This is not acceptable. And you're like, well, first, you didn't tell us exactly what you wanted. Second, if you want prototypes to actually look very good all the way through, it's going to be much more expensive. Here, we're just focusing on the function.
Yeah.
And so on and so forth, right? So the level of requirements of the client is one factor that will have a huge impact on the number of iterations, because if you keep rejecting, this little detail is off and this is off and so on, this should be smoother here, and here I see a little speck, that little defect and so on. Of course, you're going to need more iterations, but also I would say probably the manufacturer would just drop the ball and say, well, you know what? Like, that's what we can do. Can we do business or not? You tell us, because this is just getting insane. We can deal with that, right? So it depends on you. But to get back to your question, yeah, why do they ask about the number of iterations? Because if it's going to be a lot of iterations, it is going to be, I think, rather than iterations, better to think about it as, is it going to be 3 months, 6 months, 12 months, 18 months, and how much uncertainty is there, right? Sometimes you do more iterations, but then you just focus on this module of the product and that aspect of the product and so on. It's not necessarily very complicated, very time consuming. So it's more about the number of technical challenges, the time to go at it, and of course the budget, how many man hours of engineering time are going to be needed roughly, right? And again, this should be just orders of magnitude. Is this going to be $10,000, $50,000, $100,000, $200,000, right? And then for tooling, if we do like this, is it going to be 5,000 or 10,000 or 20,000 or 50,000? Like, just rough orders of magnitude. That makes more sense than asking, I think we can just do it in one go and then have a prototype that is, that functions exactly as needed, that looks good and everything is all right, right? Because if it takes you 6 months to get there and you only have one prototype, what the 6 months is what really matters to you, right?
Yes. Yeah. So change of mindset needed for sure. Yeah. That's so for if you were going to bring a new product to market, what would be the best way for you to prepare to work with your manufacturer on this in order to get the best result then, or the expected result?
So question is, what do you need to bring? Well, you need to give them a good idea about what success looks like. You need to tell them, this is the need. The product has to do this. It has to survive in that kind of environment, for that many years and that kind of use, etc. You really need to get down to documenting, describing, right? The product does this. It's got to look like this. So you need to kind of work with an industrial designer toward the beginning, because when you firm up the outside aesthetics of the product, the touch and feel of the product, down to, okay, what kind of buttons are we going to use this here, and what's the material of this, and how is it, is it going to be painted or anodized, or what is it going to be?
Yeah.
You clarify a lot of things, right? When you say, it's going to have 2 USB-C ports here, and it's going, and the output will be like this, and it's going to have this kind of display, and so on. It clarifies things enormously. Okay. But then to do that, you probably also need to work with someone technical to tell you, the usual kind of trade-offs, so you can already start to make the right trade-offs, or otherwise you're already going in the wrong direction. Because the product's got to be always on, and it's got to send the data, to the server. Okay, so what does that mean? Does it need to be on Wi-Fi? Okay, so it's going to be connected, right? Because you don't want something on battery to be running on Wi-Fi. It consumes a lot of power, right? Or is it going to sort of wake up from time to time send some data and then go back into sort of sleep mode? Is it going to send data to what? Maybe instead send data to a phone that has the mobile app and collect the data by Bluetooth, which is less power hungry. Very often you have these types of trade-offs. And if you've never done product development, you don't really know. And it's not just about electronics. I keep using examples by electronic products, but if there are mechanical elements, well, that kind of material is heavier than that kind of material, but this one maybe is more prone to fatigue. If you have a high reliability target, maybe you should use a non-ferrous metal. These types of considerations, you need to already have them in your mind. You have the concept of the product in your mind. You have a first rough idea about maybe what it's going to look like, or at least the interface for the user. At least you should know the user is going to use it. It's going to do this, and then it's going to do this, and then it's going to do this. I mean, you got to have like a concept, right? Then you need to, at the same time, as I mentioned, think of the technical trade-offs to start to make the right decisions already and go in the right direction, and work with an industrial designer who really gets what you have in mind and can start to sketch and get feedback from you. Okay. These are some essential first steps. But again, there's all kinds of questions, that you need to answer to give clarity to the team that will work on the product development. Now, if these people, they are right here in your office, and you sort of sketch stuff on the whiteboard and you all brainstorm together and so on, maybe they really get what you're trying to do. But if you're working with a mechanical team that's in Texas, and you're in Illinois, and you work with a firmware team in India, and you work with maybe the electronics in Shenzhen, wow. You got to be careful. You really got to document things for several reasons. As I mentioned, first, give them clarity so that they go in the right direction. Otherwise, you're going to keep repeating the same things, and you're going to keep seeing them going in the wrong direction and wasting time and your budget, right? The second thing is, how do you actually see if they do a good job or a bad job, right? If they say, okay, like that can be done and so on, then they have some pressure to deliver, right? But if new ideas keep popping up every week, and every week they kind of have to change direction, then there's zero accountability, because the scope, there's scope creep in every direction. So you need to give it some thought. You need to really put things down, It's going to work like this for the user. You're going to use it that way. It's going to work that way. It's going to, be compatible with that other product. It should be portable. It should not be heavier than a 6-pack of beer. But then you need to translate that into how many grams, things of that nature, right? Because again, if it's not documented, especially in China, it doesn't exist. And then down the road, of course, these things are not necessarily set in stone as you do your discovery about typical users and customers and so on, and really the technologies and the way the prototypes work and everything. Things would evolve a bit, of course, right? You should be, what is it? I think it's Bezos who said something like, you got to be stubborn about the problem you want to solve, but you can't be too stubborn about the way to fix it, right? To solve. So, and that's a good quote. So things appear and you learn because there's a lot of discovery work and you adjust. But if you already have something that's documented, then it's really relatively fast to adjust a few things and give clarity to the team about, okay, this is what changed, and everybody can think, okay, so what are the implications here, right? But if you just say, well, actually, this part of the product going to be longer because whatever, or shorter because otherwise it's going to break too easily. And people might miss some implications because, it's all about their imagination. Okay, okay, like this, okay, fine. But if they have 5 pages, the various descriptions of what the product does, et cetera, how it works and so on, then they can read it and then they can say, oh, wait a minute, it's going to be shorter, but then how does it, I don't know. You wrote here that it should, when it's placed flat on the table, like it should not wobble or anything, but should make this shorter, then the whole center of gravity and everything is different. So, it's not going to sit nicely on the table like you were thinking. Okay, right. Okay, you need to think about that. Okay, it's just a dumb example. But you got to make some effort basically to start documenting things.
Yeah, with especially with teams around the world. I mean, it's just that's just common sense, isn't it? And I think what you're kind of referring to in the run up to this is some of the earlier stages of the MPI process, and we're not exactly focused on that. We've discussed it numerous times. We've got graphics, different blog posts. I'll add some links to the show notes so you can go and dive into the MPI process as a whole. But yeah, by the time we get to the sort of phases where we're going to be prototyping, validating the different functions, designs, there's a lot of preparation work that's already gone on. Or if there hasn't been, I mean, by necessity, you might end up with a lot more work at this stage and a lot more different decisions having to be made and maybe dissatisfaction as well. But yeah, this is, you've kind of pinned it to the earlier phases of the MPI process, which I like, and that's helpful there. So good. Shall we move on to the second question?
Sure.
So at this stage, I think people will often also ask what tests are required to ensure that my product is safe and compliant. And this is, again, this is not a one size fits all answer because it's going to depend on the product and the market, right?
Right. So I think we need to distinguish between, let's say, relatively simple and unregulated products and more complex, more, products where safety is more important, and especially regulated products. For example, typically medical devices. Okay. Also automotive parts and so on. So if you have a relatively simple product, you got to do a bit of thinking. Okay, what are the things that might go wrong, right? And typically, a lot of them will come from how are the users exactly going to use the products? Okay, because users use products the wrong way sometimes and really create some serious safety hazards, right? They say, well, I don't have that product to do this, but wait a minute, this other product also rotates, so maybe I can use that. Let me try to make some kind of extension and something, and then it's going to, and then you have a really serious safety hazard, right? So if it's a relatively simple product, you do a bit of risk analysis, right, on the design of the product, and you try to think of, well, maybe if we did this like that, maybe it would be pretty clear that that is not the intended use, and maybe if we change the design a little bit like this, then it's going to be impossible to do that. Maybe that's a good idea. Okay, then because I don't want to just stick with tests, right? This question is about tests, but if you think of reliability and safety, it's about much more than tests, right?
Yeah.
It's about reviews, it's about preventive sort of risk analysis, including designing the right way and doing design reviews and so on. It's about verification and validation and, and some of that is inspection and testing. Okay. So the first thing is, as I mentioned, think of what might go wrong and try to do something about that. Then try to think when you design the product, what are some good practices? Okay. So for safety, obviously you need to look at the safety standards, and they might be compulsory, especially if you are in a place like the EU rather than in the US. Maybe in the US, they are what they call voluntary, which means not compulsory in many cases. At least for consumer product built at home, there's a lot of safety standards that are not mandatory. But if it's, for example, in the EU, but also in some other places, it's a must. Okay. So look at that. So these safety standards, they're pretty thick and pretty hard to really understand and go through them. I think we did an episode on one IEC standard, right? From the International Electrotechnical Commission, I believe that's what IEC stands for.
Yeah.
And it goes really into the details. But the good thing is these come from past issues, and there's been a lot of lessons learned, and there's standards that tell you, if you design like this, you need to think of these extra safeguards or something, right? And then you can see, okay, is the product basically safe, or is there something that might go wrong, right? That's really good. Good things to look at. And when you look at reliability, well, there's a lot of advice out there on designing for reliability and durability. And I believe we did some podcast episodes here with Andrew on the same topic. So the way to design, you're going to take that into account as much as possible. Then you get to maybe get some people to do reviews on your design, right? So maybe if you want your product to be very reliable, then you're going to have someone look at it and say, well, what if this fails and what if that fails? Do you have redundancy, for example, right? And then reliability is often connected with safety. So if this fails, then do you have a way to avoid that failure of that component or module to lead to a catastrophic outcome, right? So if you look at an airplane, airplanes are full of fail-safes, right? That's what they call it, fail-safe. So even if that fails, it's safe. So as long as you have already taken off, and let's say you have your plane has two engines, one engine fails, stops working, well, the other one should be able on its own to get you to a nearby airport, and land relatively safely, right? And there's plenty of other ways that this happens on airplanes, right? So there's been a lot of thinking here, a lot of reviews, including by the regulators, et cetera, et cetera. Okay. And a lot of simulations, as I mentioned before. So now, if you do all that, it's still good to do some verifications and validations. Okay, so verification, for example, you develop a product, it's got to, I don't know, maybe you're Apple and you develop the Apple Watch, and you want the Apple Watch to tell people, okay, this is the heart rate. Okay, well, you want it to be accurate, right? So how do you confirm that it's accurate? Maybe you're going to have the same person wear an Apple Watch on their wrist and also be all wired up with more advanced, traditional medical devices that read your biometrics, right? And then they can see, okay, is it the same number, or, how far off are we, right? But also, when you think of validation, it's also about maybe having a lot of different people tested, right? Don't do it on just one person. And also maybe let some people wear your watch every day for a month and see what they say. See if they say, well, sometimes they get really hot or something like that, right? See if the users actually find some value in the product. If they find some safety issues, et cetera, et cetera. Okay. Or if they did something that got it to fail, because you're not going to think of everything they do with their Apple Watch. Okay. Some people are going to keep banging on the sides of doors that they go through. Some people are going to, I don't know, to go diving with it. some people are going to keep it in the shower with maybe some aggressive soap and shampoo, all kinds of things. So, you can devise a test plan. And again, Andrew's talked about that in the past. You can think of these kinds of things and devise a test plan that tries to replicate these issues. But that doesn't mean, especially if you've never designed a watch before, it doesn't mean you know exactly what people would do with it and how they're going to mistreat it, right? So that's part of verification and validation. Okay. Now, and then there's lab tests. Yeah. Okay. You again, there's some standards out there. You send to a lab, they do the tests, and they tell you, is that okay or not, right? For safety. For reliability, it's not really like, okay, let's pick that standard. It's more like, let's try to prepare a standard that's really customized to our product, the type of user that we're going after, how they're going to use it, et cetera, et cetera. So it's much more custom designed, right, than for safety. Okay. If I should also mention, if you develop a product in a regulated industry, especially where safety is paramount, well, you got to beef up your whole approach, right? And there are management system standards, right? Like ISO 13485 for medical devices, or AS, 9100, I believe, for aerospace, IATF 16949 for automotive, and so on and so forth, that really tell you, hey, you got to do that. This is the way. These are the very important ways, that you get to design and develop your product and transfer it to manufacturing and so on and so forth. And on top of that, depending on the countries where you're going to sell your part or your product, there will be regulations, right? So it's not like you could start to develop a product and sell it and completely ignore all of that because your customers are going to ask for it. The regulators might ask, your distributors, and so they will be more careful, etc. So it's more a question of, do you comply or do you not comply? Okay. And in general, these certification schemes and these regulations and so on, they will steer you in the right direction. So you really need to learn how to do it the right way for your industry, for your type of product. And of course, you still need to bring your common sense with you and really think, okay, what kind of users are going to use this? What might they do? And so on and so forth, right? You need both sides of it, if that makes sense.
Yeah, it does. And it's good that you mentioned, the suppliers part in this, because maybe some businesses or some hardware startups or some entrepreneurs already know about the kinds of standards and testing that their product is going to be subject to. But I bet a lot don't. Right?
Especially startups. Usually it's like, fake it until you make it and all these kind of things. So usually they don't even want to know very often. That's what we've seen.
But I suppose with Europe, if we look at Europe and I guess the States will be, similar in time as well, but with Europe becoming stricter on the kinds of products that can be imported, those days are done. The whole fake it till you make it thing, right? And it's just like, oh, we'll get it made, get it imported. It'll probably be okay.
Yeah, let's hope so. Let's hope so. There's still a lot of crappy products sold in the EU, and things are getting cleaner again in regulated industries. Okay, but in non-regulated industries, it's kind of sad. Still a lot of crappy products, right?
No doubt.
The penalties for companies that sell medical devices and produce some fake paperwork and fake certificates and things like that. I think it's like 20 years in jail now for the EU,
Wow.
So distributors and EU representatives and so on are much more careful. right? If you remember the PPE debacle.
Oh yes, I remember.
Ridiculous situation in 2020.
Yeah.
There were all kinds of companies, selling fake products.
Cowboys.
Oh, yeah, we have cowboys. You want that certificate? No problem. We have these certificates. No problem. Right, here it is. And and people have taken note, and they don't want that to happen again. Right?
Yeah.
So they are tightening the screws for sure.
Yeah, so compliance. So compliance really is a big issue for anyone who's developing a new product, especially in regulated industries, as you've mentioned. So yeah, that's a good one.
And by the way,
and again,
it's not like there's regulated industries and unregulated industries.
No.
Like every product you put on the market is regulated in certain ways. Okay. But it's just
good
some
point.
are more highly regulated than others. Maybe I should say that. It's not like you put your product on the market and this, I can do whatever I want. There's no regulation.
Right.
That just doesn't happen. Or maybe in, I don't know, Iran or North Korea. I have no idea. Right. But if you're sitting in the EU or in the US, Canada, Australia, New Zealand, etc., there's something, there's chemical substances that are restricted or prohibited. There's certain regulations on what you claim for your product. There's some basic safety, general safety requirements, and so on and so forth.
Yeah, that makes sense. Yeah, nothing is completely unregulated, probably, but like when you're mentioning that, I think in mind, what we're thinking of is things with a kind of a higher standard of regulation, right? So you got your medical and automotive, things like that. But yeah, you're absolutely right. So as I was going to say, again, this is something that people are regularly asking about, and indeed they should be. So that's a good explanation of that. So that's two common questions around prototyping and testing answered then. So first of all, we talked about how many iterations of prototypes would be needed, and then we've just covered which tests might be required to ensure that products are safe and compliant. And I think that's, we can call a close to it at this point, but those are two real good answers to those important questions. So thanks, Renaud.
All right. Yep. Keep them coming. I remember we have some other questions from readers and listeners. So happy to make more
absolutely
about them.
Yeah, we will do. We will. There's definitely a few more already. So we've got a few more coming up for sure.
Great. Okay. All right. Thanks a lot. That was great.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.